Hello everyone and welcome to my channel. This is the A+ Tutor. Today we're going over solving systems of equations. A system of equations is simply represented by two or more equations. For example, x minus y equals 3 and 4x plus y equals 2 is a system of equations. When we solve systems of equations, we're looking for the point, the x and y value, that is true for all equations within the system. There are three ways to solve systems of equations. You can solve by graphing, by substitution, or by elimination. First, let's look at solving by graphing. When we solve by graphing, we do just that. We graph the two equations and see where they intersect. The point where they intersect is our solution to our system. So, let's graph these two equations using x and y intercepts. The y-intercept for x minus y equals 3 is negative 3, and the y-intercept for 4x plus y equals 2 is 2. To find this, we simply set x equal to 0. To find the x-intercept, we'll set y equal to 0. So the x-intercept for x minus y equals 3 is 3, and the x-intercept for 4x plus y equals 2 is 1/2. Plot these points and we can graph our lines. After graphing, we see our point of intersection is at the point 1, negative 2. So that's our solution. Solving systems of equations by graphing is an unreliable method because of the fact that this does rely on the graph being accurate. When we draw graphs, they're not always accurate, so typically you'll want to use either substitution or elimination to solve your systems of equations, but you can also solve by graphing. Second, let's look at solving systems of equations by substitution. When we solve by substitution, the first thing we want to do is solve for a variable within one of our equations. So let's take our first equation, x minus y equals 3, and solve for x. By adding y to both sides, we get x equals 3 plus y. Next, we want to substitute 3 plus y in for x in our second equation. So 4x plus y equals 2 becomes 4 times 3 plus y equals 2. Distribute the 4 and we get 12 plus 4y plus y equals 2. 12 plus 5y equals 2. So 5y equals negative 10 and y equals negative 2. We just found our y value. To find our x value, we'll simply plug that y value back into either one of our equations, and we get x minus negative 2 equals 3, or x plus 2 equals 3, and x equals 1. So our solution is 1, negative 2, which is the same solution we saw when we solved by graphing. Lastly, let's solve by elimination. When we solve by elimination, we are going to add our equations together so that one of the variables gets eliminated. So we always want to make sure we line up our equations with like terms lined up, and we want to make sure that when we do add, one of the variables will be eliminated. In this case, negative y plus y will equal 0, so we're able to add down. In some cases, we may need to multiply one or both equations by a constant value to ensure that when adding down, the terms will cancel. Now, let's add down. We get 5x equals 5, so x equals 1. Plugging in 1 for x gives us 1 minus y equals 3, negative y equals 2, and y equals -2. We can plug in our value for x into either one of our functions, and our solution is 1, -2, which is the same solution we got when we solved by graphing and when we solved by substitution. Let's look at some examples. First, let's solve by graphing. We have x minus y equals 3 and 7x minus y equals -3. We will graph these equations using the x and y intercepts. First, we'll find the y-intercept of each equation by setting x equal to 0. Then we'll find the x-intercept of each equation by setting y equal to 0. We'll plot these points and graph our lines. From our graph, we can see that our two lines intersect at a point, and our solution is -1, -4. Now, to check and make sure that we did find the correct solution, we'll plug our solution back into our equations. So we'll let x equal -1 and y equal -4. Plug these in for x minus y equals 3 and confirm. And we do see that we get 3. We do find a true solution here. And we'll plug this into 7x minus y equals -3 to confirm. And again, this is true, which means we found the correct solution. Let's look at another example solving by graphing. We have y equals -3x plus 4 and y equals 3x minus 2. We could graph using the x and y intercepts, or since these equations are both in slope-intercept form, then we can graph by plotting the y-intercept and use the slope to find the additional points. For our first equation, our y-intercept is y equals 4, and our slope is -3. For our second equation, our y-intercept is y equals -2, and our slope is 3. Let's plot these lines, and where they intersect is our solution. These lines intersect at the point 1, 1. To check to make sure that we found the right solution, let's plug in 1, 1 to both of these equations. This proves that 1, 1 is our solution. Now let's look at a couple of examples solving by substitution. We have the system x plus 7y equals 0 and 2x minus 8y equals 22. First, we'll solve for one of the variables in one of our equations. Typically, you'll pick the equation where this is easier to solve for one of the variables. In this case, we'll use the first equation. In the first equation, let's solve for x. So by subtracting 7y from both sides, we get x is equal to -7y. Next, we'll substitute that value in the remaining equation. So we'll plug in -7y for x. And we get 2 times -7y minus 8y equals 22. So -14y minus 8y equals 22. Combining our like terms gives us -22y equals 22, and y is equal to -1. Now we want to plug that back in and solve for x. So x is equal to -7 times -1, or x is just equal to 7, which means our solution is 7, -1. Let's verify this by plugging in our solution to both of our equations. We see that both equations are true, and we found the correct solution. Typically, using substitution or elimination will be more accurate than solving by graphing, so you'll typically want to stick with one of these two methods. Let's look at another example where we solve by substitution. We have 4x plus 2y equals 10 and x minus y equals 13. Again, we want to solve for one of our variables, and we want to pick the equation where this is going to be easier. So let's use our second equation, x minus y equals 13. This means x is equal to 13 plus y. Now let's substitute this value for x in our first equation. We get 4 times 13 plus y plus 2y equals 10. Or 52 plus 4y plus 2y equals 10. Solving for y gives us y equals -7. Lastly, we'll plug this back in to find our x value. We'll use x equals 13 plus y and plug -7 here. So x equals 13 plus -7, or x equals 6. And our solution is 6, -7. The last step is to check to make sure we have the correct solution. So we'll plug this back into each of our equations. Plugging this in proves that we have the correct solution. Now, let's look at a couple of examples where we solve by elimination. We have -8x minus 10y equals 24 and 6x plus 5y equals 2. When we solve by elimination, we want to combine our system of equations and cancel one of our variables. In this case, if we were to add our two equations, nothing would cancel. So we need to multiply one or both of our equations by a constant term so that we are able to cancel one of our terms. Let's multiply the second equation by 2. This will give us a positive 10y, which will cancel out the negative 10y we have in our first equation. So multiplying everything in our second equation by 2, our addition becomes -8x minus 10y equals 24 plus 12x plus 10y equals 4. We will add all of our like terms. So -8x plus 12x is 4x. -10y plus 10y is 0, and that cancels. And then 24 plus 4 is 28. Now, since we only have one variable, we're able to solve for that variable. Divide both sides by 4, and we get x equals 7. Plug that 7 back into one of our equations to find our y value. Let's plug it into the first equation. Plugging this in, we get -8 times 7 minus 10y equals 24. -56 minus 10y equals 24, -10y equals 80, and y equals -8. So our solution is 7, -8. We'll plug this solution back into both of our equations to verify that this is the correct solution. We see that this is correct, therefore we have found our solution. Let's take one last example, again, solving by elimination. We have the system negative 16y equals 22 plus 6x and negative 11y minus 4x equals 15. The first thing we want to do is we want to line up our like terms. This way we can see what's going to be easiest to combine in order to eliminate one of our terms. Rewriting our equations gives us negative 16y equals 22 plus 6x and negative 11y equals 15 plus 4x. In this case, we will have to multiply both of our equations by a constant in order to eliminate. Looking at 6x and 4x, our greatest common factor is 12, so we'll multiply our first equation by 2 and our second by 3. But we are going to multiply our second equation by negative 3 so that when we add, we eliminate that term. So this becomes negative 32y equals 44 plus 12x and 33y equals negative 45 minus 12x. Adding down gives us y equals negative 1 and the 12x and negative 12x cancel, so we did find our y term. Let's plug that y back into one of our equations to solve for x. Plugging that into the first equation gives us x equals negative 1. So our solution is negative 1, negative 1. Lastly, to check, we'll plug in our solution. After plugging in our solution to both of our equations, we see that it is true for both, and this is the solution. Thank you so much for watching. If you enjoyed this video, please give it a thumbs up and comment down below what other topics you'd like for me to go over. I upload new videos every Tuesday and every Thursday at 1 p.m. Make sure you're subscribed so you don't miss a single upload. See you next time!